Hello.
Yeah, we can see you.
Karthik.
We are going on mute because we don't want any disturbance
Karthik.
from here.
Hello.
Yeah, we can hear you.
No, no,
Hello?
net.
Can you hear us?
You can see us?
Yeah, yeah. We'll
I
go
can't
on
hear
mute.
you.
What about now? Now? Hello? There's no setting here. Yeah. It's internal. Hello?
Can you hear
Can you?
me?
Yeah.
Can you hear me?
Yes.
I can't hear you. Wait a minute. Wait a minute.
Uh, what?
Uh,
Mic. Huh? It's not our problem at all.
long time it goes off.
Test.
Default microphone connection. Default output.
Yeah. What about now?
Hello.
Yeah,
Can you hear?
we can hear you.
I can't
We
hear
can.
you. Wait, let me see voice. Latest sound.
Can you hear us?
Ah, no wonder.
Si- I'll send you the link. Just log into that link
No
and.
wonder.
Huh?
Hello.
Tell us.
Can you see me? Yeah. Okay. Hold it. So, can you hear me? Right. So, uh, okay. So here's how it's gonna happen. You can hear me, right? At that time, you could hear me. Karthik. Okay.
Yes.
So what is gonna happen is I'm not able to hear from him. You can hear him, but I won't be able to hear you back. Okay? Huh? Wait. Let me do it. I'll send you the link for that too. Hold it. Shall I? Hmm? So I'm gonna mail you, and then you can do what you want. Yeah, the only thing the mic doesn't work if he connects to this because we are connected wireless, right? I mean, on the projector. So only if it comes on the wireless and I'm connected, you can hear through the speakers. Yeah. Huh? Wait, I'm just sending. Hold it. Hang out. Okay, you sure got it. Got? Got? Are we there? No, it's clever tablet. We have only one. We are not personal. Okay. Hey.
Yeah.
So you joined it, right?
Can you hear us?
Yeah, yeah, we can hear you.
Awesome.
It's like two people talking normally.
You mute yourself because you can hear me, right? Yeah. I can mute myself.
If you guys both have speaker on, then it will.
Everybody needs to do this. Karthik, mute yourself.
One of you has to turn down your volumes. Otherwise, it won't work. Turn down your volumes, then we won't be able to hear the echo.
Now it's better?
Yeah.
Okay. So how are we going to do?
It's like over here. Should I slide over and hang out and I can talk about it?
Okay.
Wow.
Okay. So we're beginning.
Yeah, let me share the screen as well. This is live, right?
That means I need to send you also and you.
Yeah, not able to share. Hey guys, can you see my screen, right?
Hey, you can see a screen? Hello?
Yeah, we can see. We are going on mute, okay? So that disturbance doesn't come that side.
Thank
Awesome.
you. Okay, Vikram, let's start.
Okay, cool. Okay, my name is Kishle. I work as a senior system engineer at CleverTap. I started actually on Docker in 2015 as well. Like we straight out of college. We start that time. I'm running on
You went
Docker.
direct A.
No, first I was in data use.
Okay.
Then I moved to direct I like 3 years ago, and I was working on Docker there that time for a year. Okay, now I'm at CleverTap, and for us, CleverTap, we love Docker. I'm not kidding, we love Docker. Everybody knows about Docker, right? Do you know about CleverTap?
Yeah.
Yeah. Okay. So, okay, in short term, putting it, CleverTap is a user engagement platform which actually connects user from end to end cycle, right? From acquiring it to engaging them, right? On the basis of user behavior, what user did, past activities. On that, you can actually engage your customers, right? And these are right now, whatever customers you can see over here, they are one of the biggest customers which we have right now. There was Sony, Gojek, Hotstar, Book My Show. Everyone is a customer right now. Okay, this is all about CleverTap. Now we'll go to how we do Docker at CleverTap. Okay, so this is today chart which is going on today. So not 2 years ago, I joined CleverTap 2 years ago. Okay, and for that moment of time, everything was clicking. Okay, we deploy our application with the help of Jenkins, building it, and just deploying plainly with the help of SSS to the box. Right. Then in the runtime environment, we used to do Open, JDK, etc., etc. So problem was only we reached 100 servers. We were screwed. We know we were screwed because doing that takes time and manually managing different application environment. Okay, and that's we started with Docker. And believe me, like it was amazing field. Right now today, Clever Tab. Right now it's like 2,500 containers running in this current environment. In that there are 120 containers which are running for 12 hours, like load balancer, attaching into load balancer, auto scaling groups, etc., etc. Right now IPL is going on. I'm standing here doing whatever I want, right? That's the flexibility I get with the Docker. And there are some scripts you want to run like in for 5-10 minutes, that also we Dockerized. Okay, over 700 servers, everything is automated. We are handling across like 24 million requests per minute right now, 4 billion of day, and 3 billion notification. So everybody, like if you're on Book My Show or Hotstar, you get notifications, right? Like Dhoni hits a six, right? That's a push notification for you, probably coming from CleverTap. Okay, so we send approx 3 billion requests a day. Okay, and all of this is possible with the help of CleverTap, with the help of Docker at CleverTap. Okay. Okay, this is our deployment pipeline, which we use. So CleverTap is heavily dependent on AWS. We use a lot of AWS services. Okay, right now, 1 year ago, we used to do code pipeline, Docker Compose, etc., etc. Right now, this is our deployment architecture. Just push. There is Jenkins, which builds our image and push to ECR, and we just update the application tag. and it automatically updates the ECS, which actually goes and update every application tag over whatever number of instance or where the container is running. Okay, and we are up. Like it's fast. So earlier used to take like 5 minutes to deployment. Now it takes like 30 seconds, and we're good. So this is our deployment architecture. Like, and we use Amazon ECS to deploy our containers across the instance over our whole infrastructure. Okay. Huh? Yeah. Awesome. Okay. So we actually did a lot of thinking, like, okay, why we should do this, why ECS, why Docker. We did a lot of thinking. Okay, for us, let's see, like, this better. Yeah, for us, okay. So I told you when we moved to Docker, there was like 100 instance, and we are like completely screwed in our environment because everything was taking time. And for our traffic was increasing reliably, like new customers are coming in. We need a reliable software service which actually help us scale very fast on a large cluster. Okay, that's we moved to Docker. So with Docker, first project our was web scaling, right? Because traffic it is gonna hit load balancer. You need software services which actually scales up fast. If you think about this, there is a disaster scenario. You want to deploy something, right? And then which happened with us, and then you do a manual whatever. Right now, working with the virtual machines, you click. The old design was SSH and deploy. If there are 20 web servers, it's gonna take like what 30 minutes to deploy over there. We like screw that. We will make a Docker compose, just updates a tag and pull. It's done in less than 5 minutes on all 20 auto scaling groups, like whatever you want. Faster software delivery came with that, and no more configuration management tools, right? So everybody in DevOps is crazy about Chef, Puppet, and everything, right? And over time, we felt over there, okay, we have to need expertise in this, and why we need to configure our host OS. Okay, we only are concerned about application. Okay, everything should be deployable on application. We don't need to concern about host OS and the configuration management services, etc. And we also want to get the certification from PCI certified because we are a data storage company. So we think, okay, no SSH, nothing. We just have a plain core OS and we want to deploy our application on that, right? So that's why we moved. We initially we had Puppet, we ditched our Puppet, and just an application with this built-in environment with a Docker and which is shippable to the container. That's it. No more hassle, nothing. Yeah, fully immutable Docker images. When you go for compliance and a storage service, so they do a lot of checking and everything, right? Like whatever the package are used and what you want to. Like if somebody goes to the box and like install some software. So we will want to test that. So we disable SSH access for everyone and just images there, right? So no more modification of image, nothing. Just whatever it was, whatever it was at the build time, it's on the runtime. That's it. So you can do the audit trail and everything. Again, no worry about host OS. So right now at CleverTap, everything is Dockerized, but everything. Okay, we don't care about host OS or whatever. Like okay, and everything is throwable AMIs, right? If you give me an AMI, I can deploy my container over it. That's it. That's simple as that. Okay, that's okay. Faster rollback. So many times what happened whenever you do something, some deploy something, right? Let's say you deployed as an application and you know at the time the first instance, you know you're okay, this is something bad happened, right? And for you have to revert in a code, it's gonna take time, right? With repositories, which is provided, Docker and everything, you can just update the tag and it will deploy the container everywhere. So that makes my rollbacks of the application pretty fast. That's one of the best thing like I get from the Docker repo and Docker, right? Because face it, we are always gonna have something as a disaster, like if something happened on the website or we are losing traffic, we are losing data, everything can be fixed with a faster rollback site. Okay, and then we can figure out what to happen. Yeah, fast and hassle-free deployment. Now, so earlier used to happen, okay, there is repos are everywhere. You have to check in every repo on a box. Say, if you want to have a single machine host without anything, right? You have to check in every repo and let's say build and then start your execution. Okay, for this I have image. I can just say, okay, deploy this image there, and we are good, right? So this is one of fast and hassle-free deployment. Also, it gives me power to deploy my container over like my infrastructure over anywhere. I have total right now. CleverTab has 12 or 13 applications which is running. Okay, just applications. Okay, now plus infrastructure like CA Advisor or Splunk Logs or whatever, right? That gives us a 20 application. Now you have to provision and deploy over that if you want to open up a new data center, right? It's going to take you time, obviously. But if you already have a built-in image, right? You can just say, okay, this is my image, this is my infrastructure, go deploy. And it actually deploys very fast. So we recently opened up a new data center in Korea, which we were testing. It was built and up and running in like less than 3 hours. That was pretty amazing for me, at least, because I have spent like a lot of time setting up India data center with the hardcore machines in the old world. And everything is repeatable, right? Like everything. See, that's the word. Like, if you want to deploy a data center, there is something you can actually deploy. Okay, there is an image I have to deploy. Life cycle become if so efficient, you know the flow, like okay, this is going, okay, I want to deploy something and I want to discard it, okay, and the process becomes so repeatable with Docker. Is like, okay, I just have to update a tag, I have an image ready, everything is ready. If I just have to update a tag, which is also automated by Git, now I just have to click on the build and it goes deploy everywhere, right? My life becomes simpler, right? And I don't want to work every time, like every deployment is going, I don't want to sit over there, and it's amazing for me. Okay, this is that Docker and Java tabs, a short simple presentation. Any question?
Questions? Just one small question. Like, how do you? I don't know the nitty-gritty of it, but how do you basically take the tag from Git?
Okay.
Like a specific.
Yeah,
tag
yeah.
from Git
Okay. Yeah.
And
So
do a Jenkins.
sure. We do a Git branching technique, right? Okay. So now you have a branch. So you can, you can tag your Git ka branch, right? If you want to commit something, you can tag it. Okay. When the time of build environment, Jenkins get the environment. In Docker Compose, either you can update to that tag. Okay. If you're building a new image, you can just say, okay, build image and push to a repo with that tag. And in Docker Compose, I just specify pull the image from this tag. Okay. And just pulls it. That's simple.
And how is the promotion like from the dev test to the production?
Okay. So there
Can you
are.
repeat the question and then.
Okay. So how is the flow happen from dev environment to production environment, right? So we have staging all over the place. Okay. It's it's a deployment cycle. So it's for different applications. Say you have a web server application, right? You fork the branch and you just say build it. So on the branch name, okay, it builds up an image. It goes through the staging cluster, and every application is just it's like old state, which was it is like from the develop. Or say if you're a develop branch, it just builds every application from there. It's up and scale the staging cluster according to it, and deploy your application, whatever you want to test it on that staging cluster as well. Okay, everything there is Selenium and everything which actually tested unit testing, integration testing continuously, and everything is passed. Then it sends of whatever whoever is responsible for that a mail, like everyone in the team, like from event, whatever the storage we have for the processor, everybody agrees, it automatically deployed to production cluster. And yeah, that happens.
Where do images like in this easier container services? Where do keep like in the Docker hub or somewhere else images? What's your local registry? What's your registry?
Yeah. So there is.
Question. Repeat the question.
Yeah. What's my local registry for ECS, right? So right now, if you look at it, I will show you how this happens actually. Okay. So whenever someone, where I keep my local registry, right? So we use Amazon's ECR. Okay. So yeah. So to integrate with closely with ECS. Okay. I told you how this happens. Anybody?
Because this was not mentioned.
Are you using Fargate?
Yeah, no, a bit not yet. So we are testing with, and we find it's like little fall fish idea, and we already have something in place, which called as a daemon mode, right? And daemon mode actually goes and deploy for scale cluster. So web scaling is pretty much enough with a daemon mode.
Like the orchestration orchestration side.
Yeah, orchestration what we are using. Okay, so orchestration there is nothing. Okay, this is what it is. We have ECS, we have instance, and that's it. Nothing on the box. No, not even nothing. We actually don't allow anything rather than us, like three people which are actually DevOps over in CleverTap. Not the no. Apart from us, nobody can go to the box, so that we have the compliance and all
Where is Francis?
that. Yeah. So me, Francis, and there is one more guy, Ganesh. Like we are like total. You know, Miss Francis, man, you're total psyched about like, yeah, I need the security. I was like, okay then.
So one more thing, sorry. Basically the same question. But, you said that we can use a branch as a tag itself, correct? Now, if you want to do versioning on top of it, like develop, so
Yeah.
develop 01,
Yeah,
02,
yeah.
03, we can.
Whatever you want. Yeah, right.
We are able to do that via Jenkins.
Actually, I always do.
So its question was not complete, dude. Yeah.
Yeah, so basically, I'm talking about the versioning, like saying using the develop branch as the
There,
tag
okay.
itself.
You want to ask about how to tag with the Jenkins help. Okay. So tell you, I told you the thing which we used to do with Docker Compose. Okay. With this, whenever there is a build in Jenkins, okay. So we push image with a build number of Jenkins. Okay.
Okay.
There is already in any repo they have application, and you have application ka repo, and there is always a build environment variable. Okay, not always latest. So latest problem is the first file might be corrupted or something bad application push. Okay, so that we always give with the build id of whatever it is built, any branch whatever you pick. Okay, there is always a build id of that environment. You can just update in that. Okay, if you're using Docker Compose or if you're using ECR, so you can just go and say ECS, okay, use this branch. And this is the tag which you want to use. And it just goes update and everybody can pull from it. Yeah. So we are not focused on like, okay, this branch and this tag. We are just going behind build ID. So that makes my life simpler. Okay.
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 Anything else?
Yeah. Okay.
I have one question.
Yeah.
Go ahead, Karthik.
So how do you handle stateful informations like say cache or something like that? Because and logs also, because when container crashes, all your logs are lost, right?
Yeah. So how do I handle stateful things? Okay. So for that, okay, for when Docker, everything is mapped. Everything is mapped on a volume. Like if I want to do some storage, so we have a custom storage written thing. Okay, we have a custom DB written. Okay, what it's a file system DB, simple as that. Whatever it does, okay, if you everything is in memory, it just writes on like whatever there is dismounted. We know what we need to write and when I have to write. Also, whenever container crashes, right, we have a monitor over there which actually locks the container logs as well. Whenever it crashes, just monitor exit 0 exit. If it is not exit 0, it's going to log it to the system volume, and we ship it via Splunk to our Splunk manager.
What's the monitoring tool?
Splunk.
Splunk is a monitoring.
Yeah. We have two actually. Splunk, Uchiwa, the Sensu basically. Yeah. So on basis of triggers, it actually catches. So Sensu catches, okay, this is going to fail, right? This is fail, right? No exit 0, that will fail, right? It just it stored the Docker container ka log, whatever PID and whatever the stack trace we have from the application, and just ships it via Splunk to Splunk ka search it. Yeah, indexer.
Any other questions from Mangalore?
We have one more here.
Yeah.
Yeah. So if you have a stateful data like a database and
Yeah.
your host machine crashes, how do you
Yeah.
handle?
Okay, so we have actually done a quite a database stateful thing. Okay, so we are running Mongo as well as our custom DB in Docker. Okay, so think about it. So how we handle Mongo is about like replication cluster. Okay, it's like 3 Mongo are running everywhere. Everybody is in sync. So if one fails, it's in ECS we already do the always restart always. Okay, and we know it 40 minutes it will be up. So in Mongo, we can handle like that. For event store, we had certain problems like our custom DB. So at the end, we agreed, okay, if it everything crashes, right, we have a secondary container which actually automatically goes and deploys itself on like boot in like 30 minutes. So we are good there.
Okay, thanks. Yeah.
We have two more questions here.
Okay.
Come here. I can't move it.
Hello.
Yeah, I think the phone is coming to the.
I have two questions regarding the Clever Tap architecture itself. So first question is, how are you able to manage with the large amount of requests that's coming in a day? So do you make any brokers like RabbitMQ and stuff?
Sure.
Second question is, like, why did you choose like the Amazon ECS versus other container orchestration like Kubernetes and stuff?
Sure.
one last third question is the
One by one, bro.
sorry. Third question is the caching mechanism which you guys make use of. If there is any.
Okay. Okay. First question. You want to know how do we handle high traffic, right?
Right. Yes.
Okay. So to answer that, we actually test. So we have a custom written web server in our front, our load balancer. Everything is ELB. So now with the ECS, we get a flexibility.
Are you using ELB or ALB?
ELB. ELB for high traffic thing, ALB for internal whatever infrastructure. So, in case of high traffic, right, we actually have our web server scaled up very fast. Okay, we have a rigorous method. Let's say if anything, any on that box, if in a cluster, right, if CPU users reach 40%, we deploy one more ECS container on it. If it is less than that, we actually destroy. So it's very rigorous. It will just generate one instance and deploy two more containers on it. That's how ECS works for us. And because of that, we handle our traffic very easily. Uh, this answers your question.
Yes.
Okay. What was the second question?
Wanted to know like the caching mechanism which you use. Do you make use of any Hazelcast clusters and stuff?
Yeah. So we don't have that caching mechanism for us. We actually use Redis for our
Okay.
processing in middle between load web server to storage. Okay. And that's also in Redis. Yeah. We did Redis is in Docker, and which actually mounts with there are I think syncing with the file system, whatever Redis is doing. But it's there. And for storage, it's actually use a lot of memory. So with ECS, we actually allocate. Okay, okay, this is going to the box, and this is how much memory it's gonna get. Okay, so we allocate on basis of whatever the user is going to be, and it just use that much memory over that box.
Okay. Okay.
And third question.
No, like those are the only two important ones I wanted to ask. That's all.
Okay. Okay.
Okay.
Yeah, we have one more. Okay. Last.
Okay.
Yeah. Have you ever needed to roll back to a previous version once you put something live into production?
Yes, we have. Like everyone does. So the web server went down for like 5-10 minutes.
Okay.
So we actually did something. We were testing something, and it started returning 5xx very fast. Okay. So we actually realized this. We have monitor all in place. So we for older, it's happened 2 times. Okay, 10 minutes duration was one. Every box was like SSH access, and we manually deploy on each and every one. We already know okay what's the problem, and we roll back it to because of there was like code ka change because of code changes. It took us like 10 to 15 minutes to deploy our fix. But with Docker, I don't rely on everyone. If I see okay 5x is there, I just find out okay this was the last stable build and just deploy it and say like okay fix it as soon as possible. Then we will deploy the newer version. And that downtime was like what 2 minutes, 3 minutes I think.
Okay.
Now, who's this? Are you asking the question? Hello.
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 Yeah.
Only they only ask questions.
He's like no name, no name.
Okay, cool. Any further question for Kishla? Okay, cool. Thanks a lot, man.
Thank you.
Hi, Karthik. Hello.
Yeah. Okay, I have to close it now. You just.
Hello.
Can you hear us?
We can hear you.
Awesome.
Wait, now let me.
Uh, I'll share my screen. One sec.
Mine. Okay. Share screen, please.
Can you see the screen?
I can see myself.
What about others?
Okay. What else? How do I make a full screen?
Can you see the screen?
Yeah, I can see the screen, but I want to make it full screen.
Docker for CRM and its integration, the topic.
No, that's cool.
It's full screen only.
No, not on yours, man. My full screen.
Okay.
Okay, cool. Let's begin.
Okay, awesome. Hi guys, I'm Karthik. I work for Unicode as a developer for, and I manage CRM team. Okay, so I started using Docker about 6 months ago, and I found it very useful for CRM especially, and its integration. So when we speak about CRM doesn't just involve a web application which stores information about people or customers and is displayed to the agents, okay, sales agents. So one of the major problems in CRM is that it has to integrate with lot of other tools like emailing tools, calling tools, tools which are um, involving different teams. Okay, so when I started out, I did not have any Docker or anything like that. I started out with the traditional approach. So this was how my CRM architecture was initially. Okay, now in in CRM, actually, what I exactly need is one MySQL database, a CRM software. We use Espo CRM, which is an open source tool. Okay, we use PHP in the backend and Nginx as a web server, right? And in particular, Espo CRM has in JavaScript and front end, Backbone.js, and in backend it uses PHP. Okay, so in order to use PHP has its own dependency manager, which is called Composer. Okay, so we need Composer for that. And in front end, we have Node.js and Grunt.js, which basically builds the less files and compiles it into CSS and uses to compile JavaScript also. Okay, minify JavaScript and things like that. Other than that, we have error monitoring system, which is Sentry, which in turn uses PostgreSQL. Okay, and PHP which is a standard tool which we use to visualize the data, and we have Swagger, which is used to document and build SDKs for APIs, which the CRM uses or third parties of CRM use. Now, this is the entire system of CRM. Okay, so users are users of CRM who are sales or support agents. Then there are CRM dependent apps. Some of them are like Mailchimp, Autopilot, Twilio. All these are dependent apps because we use them to achieve our goals or sales goals or support goals, service goals, right? And then there are information providers who provide information to CRM, right? About customers who enter the site, who leave the site, all those things, right? So this was how my initial traditional approach architecture was. And if you look at this, it's quite a mess, right? And this is the problems we faced without containerization in the beginning. Okay. One of the major problems was emulating consistent environments, right? How do you maintain consistency between production and test environments? Your machine will have, different types of setup. Imagine you are using Ubuntu 14.04 in your machine, and in production you use Alpine, right? They will never match, right? So those were some of the problems which we faced. And one more thing is, if two services are hosted in different VPCs or EC2 instances, right? Then what? How do you emulate it, right? You have only one machine in your office, and you can't emulate these things. Like two different instances are communicating with each other. It's not possible for you to emulate it unless you have two different machines in your office too for yourself, right? And it's not very practical to use two machines in your office. um, one more problem was, how would you do local development, right? Emulating installation, setup, and managing apps are tedious. Okay. Now, do I ask my dev team to actually focus on developing features that is supposed to be used by sales agents, or do I ask them to manage all these apps like installing PHP, installing Nginx, connecting creating configurations between these apps? And believe me when I say this, that Nginx configuration for PHP is different in Ubuntu 14.04 and 18.04 or 16.04. So we had enough troubles on configuring this. And if you search in Google, it's quite a headache to find the right solutions for yourself. It's like finding a needle in a haystack, right? Now, what if the developers are new? How much time it will consume for them to just learn installation procedures, right? Even if you write installer and you need to add a minor package, you have to rewrite the entire installer to suit your needs, right? This actually happened with us. Now, one more thing is resource consumption by unnecessary packages, right? After npm install is done in JavaScript, when do you actually use npm, right? After you do pip install, when do you really use pip, right? So we don't require npm or pip installed in our machine until once the installation is completed, right? So all I need to actually run my app is binaries and sources installed by these dependency managers and source code of my application, right? The next problem which I faced was, um, just give me a moment, okay? Sorry, the battery went down, so I'm just connecting the charger. Yeah. So for moving on, so the next problem was the hours spent to configure these apps like Nginx or any other apps, for example, and expose it through Nginx, right? So for every web app that we use, for example, let's go back to the architecture here. For every web app like PHP MyAdmin, Sentry, and PHP and Expose CRM itself, I had to write a server directive which can expose it to web browser, right? Now, for every app, I have to write a separate configuration, which is a pain in the ass because, again, Nginx configuring Nginx for a regular developer who is not experienced in Nginx is not that easy. Okay, so it so every time I configure the Nginx app, let's say that by accident someone screwed it up. Now,
Yeah, is accident.
they won't really know what was the problem and how did they screw up, right? And they have to sit again and spend time on configuring Nginx all over again, right? Which consumes a lot of time again. So believe me, first time when I configured Nginx, it took me like 2.5 days to just configure get PHP get up and running. So that's the problem what we face on daily basis, right? Uh, Now, Expo CRM, if I'm building it for one party, it is well and good, right? But imagine I'm building it for different parties, right? Different people, different companies, different organization. Now, if I have to set it up in my local machine, I have to construct a different type of I mean, I have to clear entire thing which was already set up and put it back again with the, you know, it's like factory reset of applications. So it's not very, logic. I mean, not logical. It's not very comfortable to maintain two different applications, CRM applications, in the same machine, right? But they have same architecture at the end of the day, right? So these are the problems which I faced. And after Dockerization, right? This is what happened. It is much more organized than before. Initially, when I did not have Docker, it was like a tangled earphone. Everything was connecting to everything. And at the end of the day, I didn't know what was connecting to what, right? Unless I am well aware of all my architecture. And if I was the one who configured my architecture, my developer need not know that the same architecture holds true in his system, right? But in Docker, it's not like that. Now I have a service for CRM itself where my source code is mounted and it does everything with Nginx and PHP, and the developers don't have to bother what they have to do, right? Swagger service is a separate container. MySQL is a separate container. PHP is a separate container which connects to MySQL. Sentry is a separate container or series service which connects to Expo CRM, right? And it becomes a lot simpler to in terms of architecture also. right? And much more organized. So let's see what was the impact of Dockerization. Emulating consistent environment, right? Now with Dockerization, I'm using the same image all over the place. So it's pretty much equal to my production environment. And if two services are hosted in different VPCs or different EC2 instances, well, two containers can behave like two different machines as they are isolated, right? So I can spawn one container with uh, for one team and another container for another team, but ultimately I'll have two different application running in same machine, right? And since two containers are isolated, um, if you want to run two or more CRM applications to run in local, you can host it with same architecture, no issues there. And it's actually we actually use this in our office, right? In Unicode, we have two or more CRM applications used by different teams. That's one of the things. Now, local development. So for my developers, I would say you just clone this particular repository and do Docker Composer, and you have your CRM up and running. They don't have to know whether they want to install PHP, Nginx, or anything. They just have to focus on building their features, right? Features that are used by our sales and support agents. So this is one of the major advantages what I found in Docker. And one of the things I would like to bring up is the CRM application which I use or which Unicode uses is not basically meant for Dockerization. Okay, it is a standalone application and it doesn't have anything to do. I mean, we cannot use it for like how Docker build, you build it in an image and when you do container up, it will start creating containers and use it as a containerized application. It's not like that, but I found different types of advantages even if it is standalone. Okay, when I say standalone, when I bring up the container, I have to mount to a particular path, mount the entire containers app path to a particular path in my local host, which will have the source code. Okay, now packages, keep what you need, right? So dependency managers like pip and all, you can actually install whatever you require, right? And then, I mean, you have stages of build in Docker file, right? So when you actually install these things, you can just create a virtual environment, install these packages, and in the second stage, you can just copy these binaries to your next container and then spawn it, which makes the images very lightweight. Okay. Um, so these are the advantages also. Now, app configuration issues. There is no configuration to be done because every single configuration is put in image. So there is no requirement of configuration. One more thing is, irrespective of OS, the container environments are consistent, which means the DevOps team need to figure out how to configure the system, and the developer team has to focus on development. That's all, right? Now, other advantages. So what if you want to expose, like how we saw in the initial traditional approach, we had to connect every single web application to Nginx, right? In this case, you don't have to do that. You just bind the ports you want to expose and you do put it in Docker Compose YML. That's one liner for you, right? And one more thing is, so I talked about Sentry, right? Sentry is something that is being used by a lot of people other than Unicode also. So why do I have to install and configure these third parties when someone has already done it, right? So we should remember this, that we are not the only one who use third parties and we don't have to reinvent the wheel, correct? So Docker Hub provides images for hundreds of applications. So I just Docker pull, run, and it will work, right? If not, the third-party app provider will already have it in GitHub. So I just have to find the provider and use that particular image in my machine. So one of the things I mentioned was Swagger. Swagger was already there in Git Docker Hub. So I just pulled it and did Docker Compose up, and it just automatically started running for me. And Sentry also. There is a GitHub repository called get Sentry slash on premise, which basically allows written by Sentry people itself, Dockerized version of Sentry. So these are the advantages. So with Docker, you can enjoy hassle-free development. So what you have to do is Docker pull, Docker run or Docker compose up, have a cup of tea, write lots of code, git add, git commit, git push, and chill. So that's it, guys. Any questions?
Questions? Are we using Expo CRM out here or any Dockerized version of CRM? No? No questions? Okay. I think so. There no questions. Thanks a lot, Karthik.
Thank
Next is Abhishek. You got the link I sent you? You're no him on email.
Yeah, I'm finding that. Then stop sharing screen.
Okay. Then now Abhishek is going to connect. So what is the procedure, Kishal? He has to connect on mute. Oh man, I should have a standard operating procedure for all this now. Okay, sorry. Yeah, I think so. One of the comments on the YouTube was they couldn't see your slide properly. So that one. Just hello. Okay. Yeah. That's okay. This is not a problem. It's only I was in position. I was positioning you, but your slides are coming here, right? So okay.
Do you lecture this?
On this side. Oh, I need to. I need to. Need to. No, no. You go on the live. I'm trying to mute myself. Because the shut me down. Hello.
Yeah, you have to go to built-in. Who's using HDMI?
Hello. Hello.
Yeah, we can hear you, Dustin.
Hey, Karthik, can you hear us?
Yeah, I can hear you.
Yeah, I think so. We're okay, man. Or maybe you have to disconnect whole. Mine is coming.
Microphone एक चालू
Hey, come. No, first is my input has to be changed, right? So let me mute myself.
Wait. Can you hear me, Karthik?
Yes, I can.
Okay.
Cool. All right. So let's get started. Myself, Abhishek. I work with BookMyShow. I'm a DevOps engineer. So I'm just I don't know 9 months of an experience. I just have a 9 months of an experience at the whole job life. So this is the first time I'm giving a talk. Uh, Said that I'll start with my talk. So I'll be talking about how Docker is more friendly towards development. So there are two phases. One would be why development on Docker, and the second would be how will you optimize your development on Docker. So I'll start with that. So basically, the developer has
1 minute.
yeah
I think just unplug 1 minute.
yeah cool.
Yeah.
Okay.
Good to go. Can you hear us, Karthik?
Yep, yep. I can hear you.
Cool. So, as I was saying, these are the three goals, the major goals that any developer should have. So, basically, the first one would be type code and observe the changes as soon as possible. That's what.
1 minute.
Yeah. Cool.
Actually, you're still online.
Yeah, we can't see the presentation.
Yeah, we can't see the presentation, right?
Yeah.
And you have to
You can
plug
share
out.
screen.
Plug
Go to that.
Sorry.
Go to the pane there.
There's a green.
Left.
All right.
Share.
Cool. It's fine now.
Okay. You can see it.
Yes.
All right. Yeah. So there are three major goals of a developer that any developer must or should have to make a like optimized development within a shorter time and a very pretty good desirable code. So the first point would be type code and observe changes as soon as possible, and that is what all the developers actually wanted, right? The first thing what any developer would want is do the coding as soon as possible, do the debugging and all the base stuff, so that we can get ready to make and expand it on a very more larger scale. So, and the second goal is having a local development environment that is more closely related or more probably be able to work with the production environment. And the third point would be support a number of flows, which by which I mean so basically the application would have many components or many services inbuilt within it. So the development environment as well as the production environment should support all of these components to behave in the same way or the same workflow as the developer designed it for. So saying that, so first of all, we'll discuss about what the developer faces. What are the issues that a developer faces? So first one would be minor. So for each and every minor code change, he'll have to recompile the whole application. He'll have to retest the whole all the test on the particular application. The second problem would be so an application would have a number of services built within it, and if any one of the services break, and the whole application ends up going down, and that is which is called a single point of failure. The third point would be the third problem would be application is difficult to scale. Yeah. So the developer doesn't know, or he can't assume that this will be a traffic on this particular application, and I'll have to design it accordingly. So he'll be a single user centric. So he can't design it for this many number of clients or whatever. So in order to solve these three main purposes, we got introduced to microservices. And by microservices, what the advantage is, so as I told you, the application has different n number of services within it. We can break them into n number of different separate services, and we can hereby avoid the second issue that he is facing, which is a single point of failure. And whenever he makes a code change or minor changes, the recompile time or retest time that it takes for the whole application is certainly more than for whatever the microservice on which he is testing on. But this still is not faster enough, and that is why we get introduced to Docker. The So we developers we got introduced to something called a 12-factor application standard. So this is a methodology basically that every developer follows to make the whatever application or whatever the code he is writing to behave as a service, to behave as a microservice basically. So right now, before Docker was introduced, we were making use of on-prem and hardware devices basically. And when microservices got introduced, we got introduced to VMs, basically virtual machines, and they made our life much better than the hardwares. But let's see what are the benefits of VMs first. So better resource pooling, as I said. So whatever the resources are consumed by the applications, or whatever the resources that are minimum mandatory for the application, we can allocate that certain amount and make use of the other in a different purpose, for a different purpose. So the resources are the extra resources that are getting used, that is getting saved. The second thing would be easier to scale. So yeah, the VMs run on a parent host, right? So spawning a VM, creating a VM, or destroying a VM is much a simpler task than building your own hardware. And that is the reason it was a bit much more easier to scale. The third advantage was we also got introduced to cloud infrastructure basically. So in cloud, the same operations, the scaling operations, or say for example the optimization of the resources, they were much quicker and much reliable on cloud than on the on-prem infrastructure, which is maintained by us. So let's talk about why not to use VMs. So the VMs, we allocate resources, but every time we spin up a VM, we'll have to run it on a separate operating system, which by itself consumes more resource. And for each and every replica, it's like if you create an n number of replicas, it's n number of operating systems which we end up creating. So we need to somehow optimize on this part, is the next step. And VMs, that is where we get introduced to container construct. So the containers basically on the host machine, on the host OS basically. Sorry, hold on. So what I was saying is the VMs, they basically operate on a kernel level. So they spin up a separate operating system each time the new VM is created. But on the containers, on the other hand, they operate over the operating system level. So they don't need to replicate the operating system every time a new container is created. So this is where, so in the containers actually save us a lot of resources on this aspect. And as others explain, the other benefits of containerization is versioning. Versioning as in we can maintain different versions of your same applications. So for example, uh, if you're building some application and you'll have to test it on, you mark it as beta 1, create an image, and then if you optimize it more, if you like optimizing it to perform much better, then you can upgrade the version with the same image specs and everything. So that is one advantage with containerization. And so right now I'm going to talk about I've told you why containerization is it benefits over the VMs, but I'm now going to talk about why like how to use containerization more optimized, more in a more optimized way. So in order to build an application, you'll have to like go through all these processes. Basically, build the container file or build the Docker file basically, and then pull the image from the like you'll have to push the image that you built into the registry, and then you'll have to pull it whenever you're going to make the deployment. So as a developer, I don't need to do this. So on a production environment, this is a bit different. So this is very much mandatory on a production environment because they maintain something called a downtime. So they don't want their applications to they don't want nothing to be running at any point of time. So they wanted something to be running at all the time. So that is the reason they are doing this, basically maintaining image in the registry and then deploying it and vice versa. But a developer, he doesn't care about all of this. So what he needs is an application to be built and ran in the minimum number of time. So that is where so basically all these you'll have to follow in order to create in order to spin up an application. So that is where you get introduced to Docker Compose. So Docker Compose, why use Docker Compose basically? So Docker Compose consists of basically these three main components, which is a service block, volume block, and a network block. For an application to function, uh, these are the only three major requirements. For example, say it a service, say it a database, or say it an API. What it needs is basically a storage and connectivity and a way or a path to make the flow work. So the Docker Compose file looks something similar to this.
Can you expand upon?
Yeah. Right now? Yeah.
Not for me.
I mean, they can see this, right?
Oh, here, small. This camera is full.
All right. Yeah. So I've created a sample project. This is my application basically. Yeah. So what I'm doing here is if I get a hit, I connect to the Redis, I record it. It's a simple application which involves two services. One, the app itself, and the other one is Redis, its dependency. So if you do it in the other way, the normal Docker way, what you'll have to do is build this application, push it to the registry, build the Redis image, push it to the registry. Then in the production environment, pull both of the images, run their containers, do the volume mapping, whatever. But here with Docker Compose, it's quite simple. So what services block says, it's that both of these services are dependent on each other, and you can in a YAML file you can do the build, do the run in a single script. So basically, in order to run this particular application, all you'll have to do is yeah, cool. One second.
Is it?
Yeah. So all you'll have to do is say Docker Compose up, and it gets created. Now, if you want to check what is running, there you go. And yeah, so this is all that I prepared to talk about the Docker and Docker Compose. Now I'll be explaining about how we operate on our company. So basically, we ourselves are we have moved totally into Kubernetes right now. So all of our applications, except for Windows, are containerized. So why Kubernetes? Kubernetes is something which is on a it is an upgradable version of a Docker. Basically, if you want to scale or so I'll tell you the base method on which the Kubernetes works. So the Kubernetes has a concept, something called pods. So whenever you deploy a application, it will spawn a number of pods according to the resources it needs. So on this way, for example, I deploy my particular application, and let's say it has deployed 2 pods. It has created 2 pods. By pods, I mean so it has spawned 2 different containers, but it does the same thing. So whenever a client requests from outside, so there is a load balancer created over these, obviously. So whenever the traffic comes from outside, it is shared among these 2 pods right now. So what happens if the number of clients increase? That is where Kubernetes comes into picture. So there is a provision of auto scaling. There is a provision of self healing. All these supported by Kubernetes. So whenever there is more number of traffic, the number of pods tend to increase by itself, and whenever there is a less number of traffic, the pods get destroyed by itself. The second advantage of Kubernetes is there won't be any downtime. Basically, if you operate on VMs, when you deploy a new release over it, the time taken to destroy the container and deploy the new container is being saved by Kubernetes, because whenever a new release is deployed onto Kubernetes, the old pods that are existing, they remain, and a new pod is created. Whenever the pod is ready to accept connections, it deletes the other pods one by one, and this happens for each pod one by one, so that it doesn't have a downtime. And we also for metrics we are using Splunk, which is configured over these pods. So all the logs that are cool. So all the records over these all the logs and crash reports of these pods are then monitored by Splunk reports. And yeah, that is more or less our infrastructure. And thank you.
Any questions? For Kubernetes, how do you tell the developers to do local development, like with Kubernetes?
So it's all containerized, right? So if a container is not crashing, it's running properly, it's functioning properly, then it's all good to go to Kubernetes.
But if I have a dependent service, how will you basically, pull that service on your local machine and then connect it?
Yeah, so we have a concept called the pod network on Kubernetes. So a pod network exists only inside a Kubernetes cluster. So whenever you configure or when you do a release of your particular microservice onto the Kubernetes, and you have dependencies of other services.
I asked local.
Okay, local development.
It's like Minikube. Minikube is available.
Yeah.
Like a single machine cluster, you can use it.
But
On the local.
I don't see a point of having a Minikube local development in your local, because at the end of the day, you will have to test only your application, right? So you wanted to know how the other dependency applications are getting connected. So we maintain a separate environment for the testers called the SIT environment, on which all of the it's almost a replica of the production environment. So each of the testers, they do a testing on their particular application on this environment. Yeah.
Any other questions?
Any other questions from Mangalore?
Yeah, I have one question over this. So, how many clusters do you run for your Kubernetes cluster? Is it based on applications or is it based on how do you differentiate your
Uh, so it's actually balanced. It's also based on applications, and it is also based on the amount of traffic that we get.
So, do you segregate based on cluster or based on namespaces?
Only based on namespace.
So, you basically have one particular cluster serving all your pods.
Yeah, on one environment.
Okay. And
So
yeah, sorry.
yeah, so basically, our production environment is segregated on three different regions. So on each region, we'll be having one cluster up.
Okay. And what about like the question previously was asked regarding local development. So if you have one particular application, one particular namespace that you're building on, so don't you do any local testing or directly it's in the test cluster?
Yeah,
Kubernetes.
as I said, so by a deployment on Kubernetes, you mean it is ultimately a container that is running in your local, correct?
Yes.
So yeah, in order to test your dependency applications, we maintain a separate environment uh, to on which other dependency applications also do their test themselves. So all of them are it's basically a replica of the production environment. So connectivity is not inconsistent.
Okay. Thank you.
Yeah.
Any
Anything
other
more?
questions?
Do you use load balancer or ingress kind of service?
So we use both actually. The namespace service endpoints are exposed as a ingress, and then we also use HA proxy to have a high availability.
And how you are exactly maintaining like any command line tool for the Kubernetes cluster?
So our CI/CD, you mean? Okay. Our CI/CD that we use is Bamboo, and that is all both CI and the CD. So we maintain.
Regarding the client, it's like a kubectl Helm or anything else you
Yeah. So we use Helm charts. Yeah.
And how do you maintain the set context for respective clusters? Like you said, you have deployed into three different regions.
Yeah. So we maintain environment variables basically. We maintain around 4 to 5 environment variables which decide on which DC, which tier it goes to.
Any other questions? No? Thanks a lot, Abhishek.
Thank you.
So once you're free,
It's a date from there, so I have to go back.
you come now. Okay, so we're going to make a slight change because Yash has to catch a train at 8.
We can't hear you. We can't hear you. Unmute.
Okay, since Yash has to catch his train at 8 for Mandiri, I'm pushing him first and then we'll come back to Mangalore, the next two speakers, okay?
Sure. We can do last two also as Mangalore.
Yeah, I mean, you'll have to do now last two only.
Okay.
Huh?
You already done. I didn't realize that.
Notification off the fly.
Continuous integration, continuous deployment. Jenkins would get used right CI/CD. Travis is also CI/CD.
I think so I have to mute myself again. Hello.
Hello.
Can you hear me? Karthik? Mangalore?
Yeah, we can hear
Mumbai
you.
calling. Hello.
Hello.
We can hear you.
Is it?
Hello.
Yeah,
We are
we are
looking.
good.
Switch on the camera and say yes, we can.
The camera is not on.
Yes, we can hear.
Let's hear
You do. Can you hear us?
your screen.
Can you hear us?
ज्वाइन बोला हाँ पहले तो ज्वाइन कर सॉरी ज्वाइन हो गया ना हाँ। Okay.
So what should be the output?
Yeah, you can hear, right? Okay, you just unplug 1 minute because I need to mute.
Hello? Hello, can you hear me? Karthik?
Yeah, we can hear you.
Hello?
Hello.
Yeah,
Can
can
you
you
hear us?
hear me?
Yeah.
You can hear Yash?
Hello? Karthik, can you hear me?
Yes, we can hear you.
Yeah. Perfect.
Okay.
Mm. Yeah, I think there.
Wow. Perfect. Now my notes are.
Can you share your screen?
Yeah, wait.
Thanks. We can see the screen, only the Hangouts part.
I think Augustine should stop sharing his camera. Then the bandwidth will be better.
No, he
Can
can't.
He's sharing his screen.
Streaming it, right?
What are you seeing right now? Are you seeing Dr. Kapoor? No, don't look here. Here to we have the screen. उसमें देख.
हाँ
Are
लेकिन
you
मेरे
sharing
को
to everybody?
yeah
Yeah, we are looking at Docker Composer.
Oh,
yeah
okay.
perfect. Yeah, that's
You can still see Docker Composer, right? Hello.
hello. Karthik, can you see the presentation? Docker
Loading. We
Yeah,
can see
okay.
loading.
It's working. Yeah, it will be there. Yeah, first of all, happy birthday to Docker. It's the 6th birthday. So, so can you hear me now? Karthik, can you hear me? Like,
We can't.
is it still loading?
Now
Is it still loading?
we can see now.
Okay, perfect. So I'm a full-time JavaScript developer, but yes, my first love is I can say cloud and like servers and stuff. So I started this Cloud Native Surat community meetup, which is like powered by Linux. It's the first. I have a group in Gujarat. Like so, we talk about Kubernetes, Fluentd, Grafana's, and all this cloud projects, and yes, also open source contributor for like DCOS and Node.js applications like Gatsby.js and something like that. So yeah, we talk about, so as we all heard, like the project name is Docker Composer. So we all know what Docker Compose, okay, like and the importance of it, and we use it probably like like every day. So like I can assume that we all like write Docker Compose, like we all use this space stuffs and this dash and double quote stuffs like that. So yeah, but and like we also pray like hope it works. This time whether it just bring some error that string is not, space is not perfect, right? And all. So like instead of doing that, what if there is something that we can just type and it can do something like generate something like Docker Compose for us? Like why not? Because I not every time you wanna copy paste and you wanna change environment variables and stuffs like that. So yeah, it's easy to freshers to get started because like their reference documentation is about 75 minutes long. And I mean, if you just read it, like if you're not even applying or you're not even doing anything, okay. So it's difficult, like Docker Composer syntax and all the stuff. And yeah, why Docker Composer? So that you don't have to uh, always go to the terminal and change stuffs and do something again and then again try something like that. So yeah, it actually helps you to focus on what you want to like do. Like you want to apply suppose environment variable, then you can just do it instead of how you can do it. Like you have to go through the documentation and you have to check, okay, like which is the syntax, because while I was working on this project, it was like every configuration has two type of probabilities. So like either you can have object type or you can have a string type for every configuration. Like even if you want to apply node, sorry, environment variable, there are two ways. If you want to apply labels, there are two ways. So that is like, it's kind of confusing, like what you want to do. So yeah, this Docker Composer is like a simple UI tool that can help you to generate or update your existing Docker Compose file, which is I think it's in like, so this is like the demo live I want to show that how it works actually. So yeah, it's kind of like this UI where it can I make it full screen, something like that. Command Shift F. Command Shift F. Well,
What are you doing now?
full screen. So it's a demo I wanna show. So yeah, it's like you can drag and drop your Compose file here, or you can write like if you're writing like a Docker Compose from the scratch. You can use this like simple. So it's a live on this URL dockercomposer.netlify.com. So what you can do is like you can like as simple as that. You have to type a name. You have to type an image that you want to run the container name. Like so, this is like a express mode. Yes, a simple example so that we can check. Like you want to restart this. So currently these are like basic operations that we need. Obviously, I'm going to add more in upcoming time. But this is like just for the proto that how things are working. So yeah, we can have like labels. Like if you have like app, so it's kind of like a server, something like that. You can have n number of labels. You can have ports. So let's say we have 3000 port mapping to 3000 port, probably most of the time. Or we can have like MongoDB, which is 2017 node environment. So like yeah, so these are like the simple things that you can do now. And now what happens is you can add n number of services like you want. You can delete from the tool, and as you click on download, it will generate a Docker Compose file for you, so that which we can see. Can we see here? Like everyone.
White background is better.
Yeah.
Size black for demo purposes.
Wow. Okay, so yeah, it will generate something like this. So yeah, we have like the same as services, name, environment variable, and now it is like ready to run. And like you just have to do Docker Compose up and it will work. So this is like the one. Okay, now let's do reverse. Like why not let's create a, like why not let's update an existing where is my Chrome? Yeah. So why not just update a existing Docker Compose file, So what we can do is we can add file, and we can have like our Docker Compose file. So it will pick up all this configuration, existing file configuration, So you can see we had this Express and we have this MongoDB with some example, and now we can add like whatever, like if you want to change the password or something, if you want to add volume, like dot slash data to slash data slash db, something like it. And yes, just click on download, so it will generate a new YAML file which has this volume. So yeah, this is just like a prototype. Obviously there are like, I don't know, like 20, 30, 50 configurations which can be there. So now the question is why it is like that, because yeah, good, you don't have to always fight with the YAML stuffs, and it's there. Like if it will be helpful if any person who is not that technical and wants to get started. So yeah, that's the small tool which I wanted to build and which I think will be helpful. So yeah, that's it from my side.
What's built on total in JavaScript?
It's built. So that's actually I forgot the most important part. So yeah, it is on JavaScript and it can be searchable from your application once it is installed. So it can work offline also, which actually makes no sense for Docker Compose because you actually want to pull the image. But yeah, it can be as an independent app, in your OS. So it is built on Gatsby.js, which is like currently the hotshot in JavaScript. But yeah, so it has this built-in functionalities like
PWA basically.
it's a PWA. So it was like another side thing that okay, want to do service workers and stuff. So yeah, it's you can install it and you can remove it like as you want.
Are you using lazy load and suspense?
Not right now because it's like as I said, it's a POC. But obviously, but yeah, it is using like everything. So it's always on React. So it uses context API to hooks API to everything. Like these are all functional components, nothing else. And it's open source. It's on GitHub. So
Yeah,
that
show me this. I made you push for the race.
yeah, that's thank you so much for that. So yeah, it's on GitHub. It's on GitHub. Wait, where is this? Yeah. So yeah, when last night also I changed this and stuff. So yeah, so this is a POC, but obviously we can edit more, and it can be there. Like, and so this is one thing. But I also wanted was okay, there are repositories on GitHub which are like Node.js and MongoDB combination, or if you want to run Python with Postgres and stuff like that. But there is not a central place where people can come and see like okay how things are working, with multiple microservices applications. So what I want is like yes, same as Kitematic, something like that. But what I want is what if people can also contribute. So I was like we can add something like templates here, which I don't think it's there, but or it's in templates. So it's yeah, it's something like this. It's currently nothing like, but yeah, so it's like here people can have their own stacks, something like that, which they want to share with others. So there's nothing, there's just steal from it, but I'm working something like that so that people can also share their own stacks, so that others can also use it to learn and work on.
I think so that's a nice nifty tool. I think so while making this tool, you'll become very well versed in Docker Compose.
Yeah, it's really hectic, like because you have every combination, like every configuration is multiple probabilities, so you have to check okay which is too big and which is too big.
I'm doing some different version like 2 and then you're working with 3, I think.
Yeah, so that is there, and so that is also one more important thing, which is Docker Swarm and Docker Compose mode. Swarm mode is different. We have this replicas and stuff like that. So that is also not there. But that's what this actually came into my mind and I started working on it. That's a network volume. So this all three things. So that was I'm planning that we can add it, somewhere like here on the left or right side that we can occupy,
There is a linking thing. Like if you're doing a block, right? I have a block to be put here and I'm connecting application there. That actually works very well.
Sure, why not? Just you can go ahead and create an issue probably, and then we can solve like discuss. There is also one more. That's what we don't have currently network stuff, but we can have like extra network. We have also a bridge and all the stuff. We can like do smart stuffs here. So yeah, that's what I actually wanted to build. So yeah, it's there. You can use it as a standalone application.
Actually, Docker, I don't remember, but a few months back I saw Docker themselves creating something along these lines, and they had a okay. When they made a release, they basically had a video created around it.
Okay.
This was pretty interesting. I mean, this is great. This is very brilliantly done.
Yeah, so that's what actually. So like this is a POC for sure. But so the simple question is like what? So if you're a small team and there is only one person maintaining and that person is not available at the time, you want to just update a configuration, and probably your project manager or another person who is not good in Docker but they can still.
I might also.
Yeah, sure, no. That so it is open source, so the contributions are welcome. So yeah. Any questions?
Any more? Mangalore? Can take. Amen.
Hello.
No question.
No questions. Perfect.
Okay. Thank you, Rod.
Thank you.
Okay, now we move to Mangalore. Mangalore back. Mangalore back.
You can't turn off the videos.
Hello.
Hello.
Okay, cool. Jason, right?
Yes.
Okay, you need to share your screen.
Application window, not entire screen.
Share screen. Your screen share.
Oh. 1 second, Agustin.
Right.
Application, right? It is print. Becomes this one.
Yeah.
Yeah.
Is the screen visible?
Effects of Docker?
Yes.
Yeah, okay. You have to put it up. Share your screen completely. Let me click it on this. This is Karthik. Okay, Karthik.
It's the same presentation, just different slide.
Okay. Okay, you're on.
Okay. Hi everyone, my name is Jason. I'm going to speak about the influence Docker has had on our local development and also how it will help in our architecture changes. So why I'm saying how it will help is because we have still not completely moved to Docker in our production. However, we have started to use Docker in our development. First, I will like to go over what I'm going to speak about. A brief idea on what exactly we do here, and then I will move on to what problems we had, and then finally go to how Docker helped us or will help us fix these problems. So what we do at backend is basically we process some data and make this data available via APIs. That would mean that we would have a web server for processing requests, a task manager to process the data, and a database to which data is stored and later retrieved from. Currently, the way our architecture is designed is we have a monolithic architecture, which means that for some reason, if there are too many requests coming or there are too many tasks or certain attack has happened, one of these any services could end up consuming a lot of resources and bring the entire node down. And we actually wanted to move to a proper solution for this problem. Similarly, there were a few problems with the dev. Setting up stuff on cloud it's time consuming and it's hard. Testing would take time because you had to make changes on local and then push the code. Sometimes you tend to forget pushing changes and you basically you get the point, right? Every developer comes across this problem. Internet connection failures when you have with your SSH, and the cost of having the setup on the cloud. What we ended up doing is we moved our entire architecture. We wrote the Docker files required for bringing up our web server, the database, and the task manager. And so here I have listed down the advantages that we saw once we had these running on our Docker Compose. The services were well isolated. They could be scaled independently as required for our testing. We could be sure that each of the container is still running the same code um, as long as the image specified was correct. We could run on any host machine we desired. We did not have to rework on package installation if we decide to use another machine. The container can be built. The other advantage which comes to once this goes to production would be we could deploy it on machines specific to what kind of service it is. For example, the web server could be CPU intensive and we could run it on CPU intensive machines on the cloud, or we could run memory intensive services on memory intensive machines provided by the cloud service providers. Finally, all the problems that we had with dev have come to naught. The complete app setup can now be done on my local machine, thus avoiding costs on machines on the cloud. No need to wait for a fresh new setup during dev. No need to ask your DevOps for a lot of things. The entire setup is ready for you. The dev just has to start writing his code. Always have a clean setup. You did some certain testing, you were trying out certain packages. Next time you bring up a new image, new container from that image, it's still that same environment that you wanted to test on. Previously, changes had to be pushed to GitHub and then pulled on the instances to be tested. But now this problem is fixed by mounting volumes on your container when you do local dev. And now you basically can debug it quite easily and quite quickly. So that's it. These are certain effects that have helped. These are the effects of Docker, basically, how it has helped us with local dev. Any questions?
Any questions? No, we can go ahead. Okay, so next one is Amit, right?
Yes.
Okay.
Yeah. Hi everyone. So my name is Amit Thapa, and I'm gonna talk on how moving into Docker has affected our whole development cycle and the deployment of all our applications. Yeah. So how previously the DevOps process before Dockerization used to work is we had to set up test environment which was close to production for individual members in our team for testing. And even whenever we needed to deploy a new application or an existing one, if you wanted to scale, we had to keep the whole instance ready by configuring it with necessary packages using some configuration management tool, and which was very time consuming. And even the deployment strategies always differed from team to team. So based on different applications and different configurations, we had to have different configurations configurations to be made. So there were no standardization before. So if you wanted to upgrade or add or remove any packages, we had to do it in all the environments individually, and sometimes some of the test environment would miss installing the packages, which would actually throw up an error, and it was really very difficult to maintain. So what now, after introducing Docker, what we have found is that the development time for all the teams here has reduced a lot. They are more of focusing on the problem rather than struggling with the setup of the whole environment. And now all they require is just a machine with a Docker installed, and they can just run the containers and start their development. And even development across team members also have been very easier, because all they need to do is just run a container with that image and start doing the development. And Docker is ensuring that all our environments from development to production are consistent and have no difference, because that's the same image that goes from staging to production. And so using usage of content configuration management tool has reduced drastically because of Docker, because everything, the whole configuration for application comes from the Docker file and is more of done by the developers rather than the DevOps team. And regarding deployment, so it used to take a really long time before for us to deploy our applications into production. Now it's reduced to seconds. Like, it's very fast. And Docker also ensures that all applications and resources are isolated. And whenever we wanted to clean our Docker helps us to ensure clean app removal. And Docker enables us to build a container image and use the same image across all the dev environments. Okay. And now, since this whole setup using Docker, it was easier for us to introduce a CI/CD. Before, we could not introduce CI/CD because every team had a different way of deploying their applications. But now every deployment happens through Docker container. So it comes up to a standard where we don't have to do a lot of management from our side. Just the Docker container goes to production, and scaling has been very simple since we have moved to Docker. And currently over here, we are still migrating to Docker. We're not completely migrated to Docker. There are certain applications that are already running on Docker. And yeah, besides that, we are using Jenkins for CI/CD, and like how CleverTap does tagging using the build number, we actually tag it using the current date time rather than using the build number. And I think that's it.
Okay. Any questions from here for Amit? How many are using like DevOps, proper DevOps and Docker? 2, 3, 4, 5, 6. Okay. What are you using, Jigar sir? तुम लोगों का company में? हाँ. Okay. 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 Any questions for Amit from Mangalore? No? Okay. No more questions for Amit, right? Okay, thanks a lot, guys. That brings a wrap to our show and tell. Hope it was useful for people all around. Okay, I mean, now I think so. The only thing that's left is bloody eating the cake.
Yes.
Okay. Can you show the cake? Bring the cake into the room and see.
Yeah.
So, you're still sharing a screen. You can now share unshare that screen. You all guys have seen our cake, right?
No.
No, I don't think so.
You didn't see our cake.
It wasn't quite visible.
Oh.
Bring it closer.
Yeah, can you see it?
Oh wow! Cool.
Nice.
Yeah, I mean, it's for the branding.
Cool.
Okay, I'll disconnect with the customer.
So these are some props you want to see some selfies. Come.
Hi, can you hear us?
Yeah, we can hear you.
This is our cake.
The logo is engraved. Can you see the cake? Okay, they are not looking probably. They are too busy at their cake. Okay.
Nice enough that photo.
Agustin, can we cut the cake?
I can come and cut it for you.
Yes.
Go ahead. Don't wait for me. We used to bring this here. We can't cut it here. We have to take to the cafeteria.
Oh, they are taking to cafeteria.
Okay.
I think we should take
Yeah,
it to
that's what
cafeteria.
we'll take. So we'll cut the call then,
Yeah, I mean, I was going to cut it.
and we'll celebrate from our side here. We'll send you a video then.
Okay.
Okay. Awesome.
Thank you.
Thank you guys. Bye. Take care.
Unwrapping. Wrapping on that. This should have been a little bit. You can on the light now.
Stop the broadcast. Thank you.